So we are starting now. And one last time, quick roll call: Alekhya, Dev, Dhanushri, Dhanvin, Chris, Neil, Nikhil, Rehan, Ria, Sara, Shravya, Sunarka, Tansi and Varun. Wonderful. Welcome to the class again and be ready to get tortured by me for next 1 hour. Yep. Okay. So what are we going to learn today? There are two parts to it. I had sent you guys a message in WhatsApp. Some of you who are there in the WhatsApp group would have the first hand information. Some of you who are not would have to rely on your parents to know about it. Regardless, we are going to talk about the quadratic formula. How is that derived? So far I have been forcing that on you guys, saying, okay, this is the quadratic formula, this is how you use for finding solution for the value of x or any variable for that matter. So how is that formula derived? That's what we look at. And then we look at some more problems for solving the quadratic equation. And then the next thing that we're going to do is we'll start with radical and rational exponents. Yep. Is everybody clear about what we are trying to cover? Tansi, Ria, Shravya, everybody? And my request to you all, make sure that you guys don't assume anything. If there is anything that is doubtful, that needs discussion, we are here for discussing things, okay? Don't keep anything to yourself and think that, okay, if everybody understood, why it's not only me who has not understood. It's perfectly fine. I have always been one of the most, less efficient student in my class. Meaning everybody will understand and I will be saying, did I understand it? No, let me ask. And people will say, no, it's easy. It's okay. I take a little longer, that's fine. My goal is to learn. Alright, so let's move on. Everybody all set? Okay.
Yes, sir.
So, now if you guys recall what we have discussed in the previous classes, we said, okay, there are three ways of solving a quadratic equation. If I have a quadratic equation in this form, this is my standard formula for a quadratic equation. If I have to solve it for s, I can get up to two solutions. One is, we try relating that with the standard equations, a plus b whole square, a minus b whole square, a square minus b square. And that is again with the intent to convert into like a factor. And this a and b, okay, this is, let me say L and M. By converting this into a standard form, we are trying to get to this state. Or the other method that we learned was multiply a and c, bring the coefficient of x squared and this constant, multiply these two. Whatever you get, a and c. Now, let's say you got 20, then what you do is, fine, I can get 20 by 10 into 2, 20 into 1, 5 into 4, and that's it. And then you look at this combination, by adding or subtracting, then how do I get a b? That was second option. Third option was, okay, if none of these two options are working for us, then the third option is using the magic wand, which is the quadratic formula, which says if this is your quadratic equation, then you can potentially get up to two solutions for this, which will be minus b plus minus the square root of b square minus 4ac by 2a. And I kind of forced you guys to believe this. I mean, you would have learned it by yourself also, you would have seen it so many times. But from this, how does it come to this? And there is no rocket science here. It's pretty straightforward, just that sometimes we don't bother to pay attention to how it is derived. Is there anybody in the class who knows how this is arrived at? Have you given it a shot?
How we get the numbers to plug in?
No, not that way. That is the solution part of it. I'm saying, see, if I tell you area of a triangle is half into base into height. And if you say, oh yeah, this is a good formula to learn, and then you start applying it, you are perfectly fine with that approach. But I have one problem with myself. I find it difficult to believe. If somebody says area of triangle is half into base into height, my first response to that would be why? Why half? Why not 1/4? Why not 7 into base into height? Yep.
This triangle is half of the square.
Right. So you would have, and how you are able to figure that out? Because you would have thought about it. Then okay, if I visualize this as a half of a rectangle, rectangle's area is base into height or length into width. Half of that gives me this. That is understood. I'm saying this should be the curiosity for all of us. Anytime any old man like you or like me, any old man like me tells you that okay, this is the quadratic formula. First thing you should say why. And how did you arrive at this? Now we'll try arriving at that. And that would be our approach, okay? Because I know I can just let it slip by just giving you a formula, okay, use this formula, do this. You will learn it, you will do it, but then you will forget it also. That's my guarantee. So if you understand the root of it, it remains with you much longer. Let's look at it. Dhanushri, Nikhil, everybody with me, right? Sara, Neil, Sunarka. Am I asking right question here? I mean, I'm saying that okay, if I have a quadratic equation like this is my standard magic wand for finding out two possible answers or solution for x. Now I'm saying why this formula? That's what we are trying to arrive at. Okay? If you have not thought about it, you will see it happening now. Let me forget about this for a little bit, so that I can create some real estate and I'll put it in the corner. So I'm not forgetting about it. It will remain as a reference for us. Okay, so this is the equation. Ultimately, we are trying to find out what is the value of x. Okay, so eventually what I'm trying to get to is x equal to something. What will it be? Okay, how do I get to that? Okay, simple. Now look at this, ax squared plus bx, everything relating to x, I'll keep it on this side, will be equal to minus c. Yep. Now, here, what I can do, okay, let's say, I divide everything by a. So, if I divide this by a, plus divide this by a, this is okay? I'm able to knock off this guy. So now my equation became x squared plus b by ax equal to minus c by a. Now, okay, there's something interesting happening here. Now, I'm trying to see, can I get this like a something plus something squared? So I have x squared. So I have x squared, let's say a plus b whole squared, you should remember, is nothing but a squared plus 2ab plus b squared. Yeah? So I have the a squared part here, or x squared. I have something here. Can I convert this into plus 2 times b by 2a? Same thing. I'm not changing the value here. Yeah, I did not do anything. I just added this flavor. Equal to minus c by a. Now look at this. I am getting into some shape right now. Not me. My shape will not change here. This equation. Now I have a squared plus 2a, and this is probably my b. If I am comparing it to this equation. So if this is my b, then what I will do is a squared plus 2 into x into b by 2a. So 2 into a into b plus, let's add the square of this one. So this becomes b squared by b by 2a whole square, that is b squared by 2a square or 4a squared. Correct? Since I added this one extra thing here, I have to add the same thing here as well. So this becomes b squared by 4a squared minus c by a. Yeah? Now,
But why do we add 2 and then what are we going
Here?
Yeah.
see, I did not add 2. I'm trying to manipulate something right now. I'm trying to find out something in the square form. I had x squared. See, my initial position was after I moved c to that side, I was left with ax squared plus bx on this side, right, in the standard form of the equation. So, I said, okay, fine. Now I'm trying to isolate x. That is my goal. Yeah. So for me to be able to isolate x, first thing I did, okay, let me knock off the constant here I have as a coefficient of x squared. So for that I divided everything by a. So that was my approach for getting rid of a. And then I'm left with only x squared. But when I'm dividing everything by a, this became x squared plus b by a into x. Now now if you visualize that or extend that further and think about a plus b whole square formula, the standard formula, right? A plus b whole square says a square plus 2ab plus b square. So I have a square. I have something into something. I'm trying to convert that into form of 2 into a into b. So to get a 2, I have to divide by 2 also. So I'm not changing the value. B by a into x remains the same thing. I'm just representing that differently by having a 2 in the numerator and the denominator both, which can kind of knock off each other. Yeah? Dhanvin, did that answer? Dhanvin, I'll not let you go unless you say yes.
Yeah, I understood.
It makes sense, right? I mean, again, this is not only for Dhanvin. I'm just trying to make sure that everybody is following this. I'm not trying to do anything cryptic here. Yeah? Dhanushri, Neil, Sarah, Shravya. Everybody with me?
Yeah, sir.
Chris, making sense? Rehan, Sudarka, Tansi, Ria. Okay. So now, again going back to the same flow, we have this equation. I'm trying to isolate x. That is my goal. So I said, okay, fine. This one is easy picking. I can move it to that side. Then I'm left with something like this. I'm saying, okay, I have to isolate x. Let me get rid of a also. For that I divide everything by a. Because that's one trick that we have learned, that if you have an equation, you can multiply each and every term by a number or divide by a number. Your equation doesn't change. Yeah? So when we did that, we came to a point where I have x squared plus b by ax equal to something. On this side, I am trying to convert this into a perfect square form. X squared plus this. So I am trying to convert x squared plus something. A squared plus 2 times something. And then I realized, okay, if this is my x is my a, this is my b by 2a. So this is how I have a squared plus 2ab. What is missing is b squared. So this is my b, so this is my b squared. Yep. So with that being done, now what is that we have come to? I'm erasing what we have at the top. Okay. So now I have x squared plus 2 times x into b by 2a. So this is a, this is b, plus b squared, or I'll say b by 2a square whole square. Okay, let me keep it that way. Okay. Now equals b squared by 4a squared minus c by a. Let's do this together. So this becomes LCM of this will be 4a squared, and this becomes b squared minus what I don't have is 4a. So 4a into c. Now it is taking some shape. Yeah? Are you guys with me? Are you able to follow this calculation? I'm just adding two fractions, right? So this LCM of these two 4a squared and a will be 4a squared. So that's what I put here. And now I'm calculating this. So b squared into, LCM is 4a squared. So one time of that is 4a squared. So 1 into b squared. I got a b squared minus, when I'm taking this term, I have only a here. So if I multiply that by 4a, that is how I get 4a squared. So 4a and times the numerator. So that is why each term has 4a. So what we got here was, if you look at the left hand side, you have x plus b by 2a whole square. A square plus 2ab plus b square. So a plus b whole square equals b square minus 4ac by 4a square. Yeah? Or now we are getting serious. So if I have something square, this square equal to this. So that means ax plus b by 2a, if I do a square root both the sides, will be equal to square root of b square minus 4ac by 4a square, which is 2a whole square. Yeah. So when I do a square root of this one, and then whenever you do a square root, you get a plus and minus both the values, right? Square root of 16, square root of 16 gives you plus and minus 4, right? Same way, square root of this gives you plus and minus of this thing, which is nothing but plus and minus. This part remains inside the square root, and you know that square root of a square gives you this. Now x equals, do everything that side, minus b by 2a plus minus square root b square minus 4ac by 2a. Take 2a common here, it becomes minus b plus minus b square minus 4ac by 2a. Sheer waste of time. You will say nobody in the world is going to ask us to prove this formula. And we are not proving this formula for anybody else. We are trying to reaffirm, make ourselves believe that if somebody ever dared to give me a formula, I know how this formula came into existence. Everybody with me? Tansi, Alekhya, Nikhil, Rehan, Sara, Neil, Ria, everybody with me?
Yes, sir.
Tiniest of the doubt, let me know. Dave, Varun, clear beta?
Yes, sir.
Okay. So here's the deal. Any mathematical formula, any mathematical problem, science and math are two subjects. In my mind, I might be wrong. I have huge respect for every subject, but science and math are two subjects that gives us the ability to prove everything that we are being asked to believe in. This was one example. Yeah? And then I'll give you guys a long lecture saying this is the reason why I chose science and math as my favorite subject. So now, if anybody says there is a quadratic formula that you can use for solving a quadratic equation, and that gives you two possible values of x, which is minus b plus minus b squared minus 4ac by 2a. You will just smile at whoever gives you this formula, because you also know how this formula is derived. Yeah? So instead of you being a follower, you are a creator now. You can create this formula by yourself. Yeah? Make sense? Alright. So then, let me do a quick check. Is everybody able to follow whatever I did on the board? Was there anything doubtful? Sara, Ria, Neil, Shravya, anybody? Varun? No? See, I don't get this many likes even on my YouTube videos when I post it. But I'm liking the likes that I get here in the class. Thank you. Alright. And that just reaffirm that, okay, whatever we are doing, at least we are able to be on the same page. Now let me pick up one problem that we want to solve. Let's just look at one equation and we'll see. We'll not probably try solving it. At least we'll try to put our head around it to see how we have to solve it. I'm reading one problem for you guys, okay? Before I read, let me first try it. The problem is like this. 1 by 1 minus 1 by this plus 1 by x plus 4. Okay, this is the equation given. If x is greater than 0 and x is not equal to 3, which of the following is equivalent to the expression above? If x is greater than 0 and x is not equal to 3, which of the following is equivalent to the expression above? Let me write it down. A is 2x plus 1, B is x squared plus x minus 12, C is x squared plus x minus 12 by 2x plus 1, and D is 2x plus 1 by x squared plus x minus 12. So let me read the question for you guys. We have been given this expression 1 by x minus 3 plus 1 by x plus 4. And then the conditions given are if x is greater than 0 and x is not equal to 3, which of the following is equivalent to the expression above? What would you do first? I want to read your mind. I am not in a hurry to solve this problem. I want to make you guys think and tell me how would you start?
I would try to simplify the denominator first.
Yeah. Okay.
So I would try to just like pick x as like a random number, which is looking at the parameters. Like you could say 1, and then you can just plug it in to those, and then try simplifying.
Okay. Okay. Any other thoughts? Give me the thoughts. Thoughts are worth $1 million. Let's see how many $1 million I can get from you guys. I got $1 million already. Yes. See, I'll become super rich today. Okay. Depending on how many thoughts I get from you guys. So again, I'm sure there is a lot going on in your mind when you look at this kind of question. I'm reading the question one more time because that aligns with my forceful method to my magic wand. Read, analyze, and then do it. So we are trying to read and analyze. So I'm reading it again. As I keep claiming that when you read a question multiple times, it becomes much easier, much simpler to us. So the equation says 1 by 1 by x minus 3 plus 1 by x plus 4. If x is greater than 0 and x is not equal to 3, which of the following is equivalent to this expression? So I've read it enough. I want to hear your point of view. What would go in your mind? How would you approach? Don't struggle for solving it. Tell me what is going in your mind. Shravya, Riya, Dhanushri, anybody. Alekya. Tansi is thinking something. Go ahead, Vita. Tell me. Okay, keep thinking, I'll come back to you. Rehan, Sarah, anybody? Yes, Dave.
Question, I would try making the top equation that we have. I'll try simplifying it and condensing it so it's in a form with x equals, and then I will plug in like values like 1, 2, and so on the E, B, C, and D, and whichever is equivalent to the top equation.
Yeah. So, okay, let me not haunt you guys so much. Yes, Dhanushri, go ahead.
I would try to change
I'm sorry, Vita, one more time.
I would try to change maybe.
Right. No, so I think everybody is saying similar thing. See, if I have this equation that if x is greater than 0, x is not equal to 3, this is probably far-fetched for me, okay? I don't know if putting some value for x here in this situation would be that easy. I mean, we have one clue, x is not equal to 3. What happens is if x is equal to 3, this becomes 0. 1 by 0 is infinity. So that's why it is already telling us that, okay, this is not equal to 3, so that it doesn't become undefined. But I will probably come to this little later. If I were you, this is what I will start with. Okay? That okay, let me first simplify this. This looks very, very uneven kind of a thing, right? How do I deal with this? All the equations that I have here, these look much more amiable, friendly, relatable, right? This guy looks very weird. Let's first simplify this. So with math, every problem that we come across, our first attempt should be, how do I simplify it first? Yeah? Connect with me? So now when I have this, let me forget about everything here and try simplifying this. What I will do is, okay, 1 by something. Let's get this thing. So the LCM of this will be something like this. X by, so this is like adding two fractions. That's what I'm doing. And I don't know what is the value of x, so I'll kind of keep myself unaware of this, and I'll treat this as one number, this is another number. My best LCM is this. Now when I take this, it becomes x minus 3 is one factor. So what is missing is x plus 4, and my numerator is 1, so this remains this. And then I have a plus sign. X plus 4 is here, so that means I have to put x minus 3. Now this is looking better. So this is now, if I look at this, let's forget about this. Let's remove this for now, so that we have some real estate here. So this becomes 1 by x plus 3 plus x minus 3. X plus 4 plus x minus 3. So this becomes 2x plus 1 divided by x minus 3 into x plus 4. If I flip it, I mean now 1 by something, so this flips, this goes to the top, x minus 3 into x plus 4 divided by 2x plus 1. Now when you explode this, this becomes x squared plus 4x minus 3x. So this becomes x squared plus 4x. Now this will minus 3x minus 12 divided by 2x plus 1. So this becomes x squared plus 4x minus 3x. 4x minus 3x is x. So x squared plus x minus 12 divided by 2x plus 1. If I go back to my original question, the four options that we had were x squared plus x. Okay. So I had four options, 2x plus 1. That is not the case any which way. So first option rule out. X squared plus x minus 12. That is only the numerator part. Denominator is not there. So second option also I'm ruling out. Third option was x squared plus x minus 12 divided by 2x plus 1. This is my third option. That was there's the question. Fourth option is just reverse of this one. So 2x plus 1 was the numerator and this was the denominator. So this is my third option. This is looking to be right. Now there was one condition also given that says if x is greater than 0 and x is not equal to minus 3. So not equal to minus 3 was in the original state itself. If I would have had x equal to 3, this whole thing would have gone for a toss and it would have become undefined. So this part is taken care. Now since x is greater than 0, x is greater than 0. Now I don't really care about it, right? Whether x is greater than 0 or less than 0, it doesn't really matter. It is still in a defined state. So again, you guys will think that okay, was this related to quadratic equation? It is eventually a quadratic equation, right? It was a little different problem. But what we had to do was we had to look at how do we solve it. Now if you go on solving this one, I mean you already have a factor like this, and this cannot be 0. That means this is not the case. This is not 0. So x is, I mean x plus 4 could be 0. I mean this has to be 0. So anyway, we don't have to worry about it. The question was simple. It was saying that you have an equation like this. What is my equivalent quadratic equation? And that's what we tried doing. Tomorrow if you have to solve any quadratic equation and find out the values for this, you will not really worry too much about it. You have three options to choose from. One is your mapping it with the standard formula a plus b whole square, a minus b whole square, and a square minus b square. Second option is multiplying the coefficient of x square and c, and then comparing that with b to see how do you get that. And third option is eventually the quadratic formula that we proved just now. Is that okay so far? Varun, Priya, Dhanvin, Sunarka, very quiet today again. Are you with me, beta? Everybody okay? Okay. Dave, all clear? See, you guys are kind of trapped, okay? Meaning, you never know whose name gets called. That is not to bother you, but that is my way of affirming that whatever we are doing in the class, I'm able to reach everybody. Okay? What happened? Rehan got scared of me and dropped off. I think it's because of the network, not me. I'm not that scary, I believe. Okay, so let's pick up one problem. Okay, one problem, and we'll just try solving it the quadratic equation, and I will make it up on the fly. Let's say if I have an equation x squared plus 3 by 9 x plus 19 equal to 0. Now don't try solving. Don't try solving. Not every problem is supposed to be solved. If you have a quadratic equation like this and somebody says solve it for x, find out the possible values of x. And again, Tati, don't try solving it. It's okay. So, if you have a problem like this, what would go in your mind first? That's what I'm interested in. How would you approach? How would you process your plan? Yes, Tansi, go ahead.
I would use the formula ax squared plus bx plus c. Like I'm trying to make the terms on the equation relate to like a, like when that's the actual quadratic formula.
I'll complete. Yep, okay. Alright, yep, yes, sorry. You'll straight away jump onto quadratic formula, okay? What will go in your mind? What will go in your mind? I want to poke a hole in everybody's mind. Yep, tell me.
I don't like the fractions, so I would probably just multiply by 9 on both sides. Then I would do quadratic formula.
That is one, yep. That's another approach, yes, Pranit. Little louder for me.
I see if I could factor the equation first, so I can see if there's like an easier approach to this. If not, maybe so
Okay. So see, this problem might look scary to some of us when we try solving it. But here as a group, we are much stronger than this problem. I got 4 different options. One option that I got from Tansi and Said was that I will just map this with my standard equation and find out the value of ABC and apply the quadratic formula straight away. That was one approach. Second approach that David gave me was that I don't like fraction. I will multiply everything by 9 so that I have a much easier way of looking at things. So it becomes 9x squared plus 3x plus 19 into 9, 171. Now you say, how did I find it out? Because when I was small like you guys, I was forced to memorize tables till 20. So till 20 I'm okay. So anyways, now this is looking more like an equation. Now first thing I will do is, I will check, is it in the form of this square, a square plus b square? See, all are plus, so only option I have is a plus b whole square form. Is it looking like in that form? It doesn't seem so. This is not a perfect square for me. So I will probably not go there. Second option I have is, look at the coefficient of x square and this is my c. Multiply these two, 171 into 9. I don't know the table of 171 for sure. So I will multiply it. 9 7 plus 63. 9 plus 6. Life is getting more interesting. Now if I have to factorize this, too much effort. I will go for a simpler route. I have a magic wand. Quadratic formula, just apply that. And with a quadratic formula, there is one more thing that we have to do. you don't really want to do the entire calculation. What you want to do is find out the discriminant first. Find out the value of the discriminant. And if you get this value as positive, then it makes more sense for you to proceed. Otherwise, you can say that the solution is unrealistic. Yeah? So these are the things I want you guys to practice. Make it like when you guys go to school, right? You have your sequence of events always lined up. That okay, once I come back from school, I'll put my school bag to the side, look out for something in the pantry, make myself full, have a glass of water, settle down, watch TV for 10 minutes, and then I'll think what to do next. So likewise, those sequence of events, that is how you should approach a problem. When you break it into sequence of events, it becomes more methodical and you don't really have to struggle to find a way out. Does it make sense to all of us? Except me? Everybody? Lekhya, Sunarka, Ria. Ria, what happened, beta? Upset with me? Not talking at all? I'll do it? Okay. No, I'll keep checking with everybody, okay? Alright, so far this is making sense to all of us. Now let's change gears. I will talk about exponents. Radical and rational exponents. Is that okay? Okay. So this takes us to the next unit actually. Not next unit. Within advanced math, this is the next chapter, which is about radical and rational exponents. Yeah? Now, what is that we all know? What is that we all know with respect to what is a rational exponent and what is a radical exponent? What is exponent in the first place? Can somebody tell me quickly? And remember, I am a 5th grader, okay? Yeah.
The number of times a number is multiplied by itself.
Okay. That's a simple definition, okay? If I have this something like this, I will call this an exponent, where this is the exponent actually, the power 2, 3. This is my base and this is the exponent. That's how we call it. And the way we interpret this is nothing but this is exponent. Now I'm saying what is radical and rational exponents. So I'm not letting things stay easy for us. I'm trying to make it complicated, isn't it? Anybody aware of what is a radical exponent or rational exponent? Any definition? What is a radical exponent? What is a rational exponent? Yeah, please.
Isn't it when the exponent is like a fraction?
You guys have to keep on decoding each and every word that we come across. So what Pranit is saying is, rational exponent is where the exponent is a fraction. Now, I said rational exponent. I have two words here, rational and exponent. We just figured out, or we just talked about what is exponent. So here this is the exponent definition, where this is called the exponent of 3 or the power of 3, and this is my base. So this word we know. How about rational? We all have learned what is a rational number. Any number that can be represented in the form of a fraction is called a rational number. 1 by 3 is a rational number. 5 by 9 is a rational number. Even 8 is a rational number because I can always write 8 also in the form of a fraction. So any number that can be written in the form of a fraction is called a rational number. So when we are talking about rational exponent, what was my exponent here? 5. If I even end up having 3 to the power 2 by 9, I have an exponent where the exponent is in the form of a rational number. So this is called rational exponent. Does it make sense? Varun, Dhanvin,
Yes, sir.
Nikhil, yep. So, simple thing. We are just extending our understanding of things step by step. We all knew what is exponent, we all knew what is rational number, we are mixing the things together. And that is how it becomes rational exponent. Meaning, when you have some number represented in the exponent form, and your exponent or the power is in the form of a rational number or a fraction, That is called rational exponent. Now you will say, why do I need to worry about it? I'll show you guys an interesting situation. If I say, find out square root of 16, you will say easy peasy, 4. Because you said, okay, it is 4 square, and so square root of square nullifies each other, only gives me 5. Yeah? So far life is interesting. Let me make it more painful. And how will I do it? If I say 5 to the power 1 by 2 into 5 to the power 8 by and this is when it will look scary on its outlook, okay? 1 by 2, 8 by 4, or maybe somebody says, okay. Okay, more interesting. I mean, we know power, something 2 to the power 3, I know 2 into 2 into 2. But what does 2 to the power 1 by 3 mean? What do I do? Yep.
It's the same thing as square root
Cube root, basically. So rational exponent becomes a way for us to deal with higher powers of the root. So now let's try relating it. If I have 2 to the power 2, that means 2 square. If I say 2 to the power 1 by 2, this is another way of representing the square root of 2. If I say 3 to the power, let's say 8 to the power 1 by 3, it is nothing but another way of representing cube root of 8. It's the reverse of the exponent power. So if I say 8 to the power 3, I am saying 8 into 8 into 8. If I say 8 to the power 1 by 3, I am saying cube root of 8. Meaning, I have to find out what will be the value here. It will be like this. 8 is nothing but 2 to the power 3. 2 into 2 into 2. So it becomes a cube and cube root, and that is how you get a 2. So basically, whenever we deal with squares, we are fine with normal exponents. When we are dealing with roots, that is when the rational exponents play a great role. So is this okay so far to digest, or Alekhya, Neil, Sarah, everybody with me? Nikhil, okay?
Yes, sir.
Riya, okay? Rehan, all okay? Rehan, are you with me, beta? Okay. I'm assuming Rehan is saying okay without saying a word. Let's move on. So before we try dealing with the rational exponents, let me first give you one easy information. I talked about two things, rational and radical exponents. It's the same thing, just two different representations. If I say 2 to the power 1 by 3, this is nothing but a rational exponent, because my exponent is in the form of rational number. That's why it's called rational exponent. If I represent it like this, 1 by 3 is nothing but cube root of 2, this is called radical exponent, because the radical form of representation. So rational and radical exponents are the same thing. These are just two different representations. Okay? Does it make sense so far? Okay. So first of all, the only promise that you guys are going to make is you will not get confused between rational and radical exponent. Both are same thing, just two different representations. Now we are going to break our head with what is rational exponent and how do we use them actually. So before we do that, there are a couple of basic understanding about the exponents that we need to reaffirm, and those are, let's say if I say x to the power 2 into x power 3. How much that would be? Okay, anybody on the screen? X to the power 2 into x to the power 3. How much is that? X to the power, how much? Okay, so I don't know, you guys are being quiet, that scares me. Even if you give me a wrong answer, I'm fine. If you don't give me an answer, it becomes very difficult for me to assume anything or conclude anything. So let me, and that would mean I will have to waste your time a little bit on going back to the basic underlying principles. What happened? Everybody okay? Alright. So now here's the thing. If I say x into x into x, I have 3 times x being multiplied with each other. Let me not write x because x becomes a little complicated because multiplication sign is also like x only. If I say y into y into y into y, I have 4 times y, that becomes y to the power 4. No confusion? If I say y to the power 4 into y to the power 2, Pranit will say y to the power 6. It's very simple. But y, I will go in a simple way. Y to the power 4 is nothing but y into y into y into y 4 times. And then I have y squared. That means again y and a y. These 2 y is for this one. These 4 y is for this one. Right? So now if I look at it, it becomes 1, 2, 3, 4, 5, 6. Y to the power 6. What happened is my power got added. When I multiply two numbers, two exponents with the same base, my power gets added. That is my first formula that I will keep in mind. That's what we saw here, right? If you say 3 to the power 2 into 3 to the power 5, what you are saying is 3 into 3 2 times, and then 5 times 3 into 3.
So we 3 to the power of 7.
3 to the power of 7, correct? So what is happening here is when you are multiplying two exponents with the same base, the power gets added or the exponent gets added. So this becomes our first thumb rule or rule of thumb, saying if I have x to the power a into x to the power b, my base is same, only my exponents are differing. It can be same also, I don't really care much about it. As long as my base is same and I am multiplying them, it just adds the exponents. Yep. And if I do, let's say 3 to the power 5 divided by 3 to the power 2, what happens? It subtracts. And that is very simple to see, right? 3 to the power 5 is 5 times 3. And then 3 to the power 2 is 3 times 3. Now, opportunity to play. Tic-tac-toe. This one gone. This one gone. What do I have now? 3, 3, 3. That is 3 to the power 3. What is that? 5 minus 2. So, whenever I am dividing exponents with the same base, meaning x to the power a divided by x to the power b, it will give me x to the power a minus b. Is everybody with me so far? Riya, Nikhil, Varun, Neil, Sarah, Rehan, Savya, Sunarka, Dhanusri, everybody? Chris? Dev and Alakya as well? Okay. So this is my second rule of thumb for exponents. Now the third rule of thumb is, let's say 3 to the power 2 to the power 3. What happens? It multiplies it. And again, we don't have to worry too much about memorizing it. You can always look at a simpler sample, right? Like, instead of giving you this formula straight away, I'm saying, okay, let's look at the numbers. So this is like 3 squared into this has power 3. So whole thing is multiplied 3 times. Now I can apply this formula. I have all the same base and the exponents. They will get added. 2 plus 2 plus 2, 6. That is equal to 2 times 3. So that becomes my third rule of thumb, which is x to the power a whole thing to the power b becomes x to the power a times b. Remember this. So here I think there are kids joining from the next class. Okay, I think they disconnected. So here, when I have a situation like this, when I have these two situations, my power is getting added. When I am dividing, my power is getting subtracted. And when I have everything in the bracket and then there is a power, the exponents are getting multiplied. These 3 rules of thumbs are okay, right? No problem with that. And this will become handy for us when we are dealing with rational exponents as well. So that's what we'll look at now. But before we do that, I have an interesting problem for you guys. 4 to the power 0, 100 to the power 0, x to the power 0, they have all one value 1. Okay? All have one value 1. Why? Can you try proving it? I'm saying I agree that all the numbers to the power 0 gives me 1. Except when the base is not 0. Oh, not 0, right? I mean, if I say 0 to the power 0 is also 1, that will not be correct. So, any number to the power 0 will give me a 1. But I'm not happy with just that answer 1. I'm saying why? Can somebody try proving it? These are the mysterious things that I like. Now let me, okay, yes Nikhil.
40 to the power of 0 means 40 multiplied by itself 0 times, so there's no zeros to multiply. 40 times itself 1 time, which is the power of 1. 40 is the power of 1. But 40 times itself 0 times is just going to be 0 because there's no 40s to multiply.
Okay, yeah. No, a good thought, but not convincing enough. Let's see what Panit has to say.
So if you take like 4 to the power 2 divided by 4 to the power 2, because of the rule of division, you would subtract 2 minus 2, which would give you 0, and then since 4 to the power 2 divided by 4 to the power 2 is the same thing, we have 1.
Right. Right. No, so Panit has been in the class before. I'm sure he has dealt with it in the past. If not, if he doesn't remember that and he is able to put that thought with a fresh perspective, that's a good thing. Now, simple. Whatever we have just done, we are just going to relate to that. We just learned that x to the power a divided by x to the power b gives me x to the power a minus b. Correct? I'm saying if I have, let's say, 40 to the power 0, I can say 40 to the power 1 minus 1. That is fine. X to the power a minus b. What would that mean? X to the power a by x to the power b. My a and b both are same. What are we getting here? 1. You can choose any number. 100 to the power 0 is 1. I'll say, okay, 100 to the power 0, okay, I can say 0 is 3 minus 3 is 0. That means 100 to the power 3 divided by 100 to the power 3. Nothing very tricky. It was a fun element of it, okay? So we all have seen, yes.
What about 0?
0 is a problem. 0 is actually, 0 itself is a very undefined number. Now look at this. 0 to the power 0. What we are saying is 0 to the power, let's say 1 minus 1. Okay? So you are saying 0 to the power 1 divided by 0 to the power 1. 0 by 0 is never 1. Because 0 is undefined. If I am saying I am giving you $0, what am I giving? If I give you 2 billion times $0, what does it mean? It remains a 0. Right? So that's how you will take it. So now this is another interesting part. I mean, this could be a fun event, right? That you guys can do. This is not explained anywhere in the book, right? I'm just telling you that okay, when you play with math, these are the things that you learn for yourself, and that becomes a riddle. You can ask this question to any of your friends, and let's see how many of us actually pay attention to this. Wherein everybody knows this formula, but we don't really think about it, right? Making math fun is what my goal is. Yep. So what did we see? We saw that what is a rational exponent, what is a radical exponent. They are eventually the same. They're just two different ways of representing things. We looked at our concept of our understanding of exponents, how the three rules of exponents work: multiplication, division, and the power. Now we'll apply those for solving more problems for us in the coming class. But before we do that, can somebody open the garage door for me? Because there will be kids waiting outside. We'll continue with our class, but just make sure that those kids don't think that there is no class for them today. Okay. What happened? Okay. All right. So to continue with, we have a couple of minutes. So what the clue that I want to give you guys is, if somebody says 3 to power 9 by 18 into 1 by 6 divided by 3 power 4 by 9. If we had dealt with this kind of problem before, without taking into consideration the exponent formula or exponent rules, this would have looked scary, trust me. If I were you, I would have been scared of this kind of thing. What do I do with? I know power 4, power 3, power 18. What is this nonsense? Right? That is where the anxiety starts. But now since we know that okay, exponent gives us a way to approach them, we'll look at some of the problems, we'll try solving them tomorrow, and we'll deal with the rational and radical exponents in the class tomorrow. We'll do a little bit of practice, because just me giving the theory to you guys doesn't take us anywhere. We'll try dealing with this tomorrow and look at some of the interesting aspects of how do we deal with this kind of situation, right? If somebody says, okay, 4 to the power 3 by 8 multiplied by 8 to the power cube root of 8 square. This doesn't look so very easy, right? I have some stupid power here. Here I have a square and then I have a cube root. But if I simplify this, I'll say, okay, this is 4 to the power 3 by 8 into 8 to the power 2 by 3. Now I have a more amiable way of looking at this whole problem. So we'll deal with that in the coming class, and we will look at different possible ways to simplify things, and then we will break it down. Careful with the wires and things moving around you. Alright? So with that being said, I will let you guys go. Enjoy the rest of your evening. I'll come back to bother you tomorrow same time. Yeah?
Yes, sir.
Thank you, sir.
Present.
Alright. Bye bye. Bye bye.